Hello everybody, today I will be explaining the clipping circuit. The clipping circuit is a circuit that takes an input waveform and clips or cuts off its top half, bottom half or both halves together. This circuit will take the input, for example a sine wave, and it will clip apart from the top or from the bottom or from the both sides and will be showed as an output. Okay, we have given values V battery, which is represented as E on the circuit with this 3 volts, frequency equal 1 kilohertz, the resistance is 10 kilo ohm, and the input is an AC signal with 5 sine omega t. I will start with plotting the input signal, voltage, omega t. The given is 5 sine omega t. A sine wave with an amplitude of 5 volts for the positive half cycle, and an amplitude of minus 5 volts for the negative half cycle. I will be dividing my analysis into two parts. The first part I will be analyzing the effect of the positive half cycle of the input voltage on the output V2, the second part will be the effect of the negative half cycle on output V2. I will start by drawing the circuit. Okay. In the first case, the positive half cycle here. As we can see, the voltage is varying between 0 and 5. Okay. We know that in order for the diode D1 to be in the forward bias, in order for the diode D1 to conduct, it needs an anode voltage greater than the cathode voltage. So this node, which is referred to V2, should be less than V1. So V1 should be greater than V2 in order for the diode to be on. While when V1 is less than V2, the diode will be in the off mode. So let's start. The voltage here will increase from 0, reaching a value here. From 0 till this value of V, we will be working in the second case where V2 is greater than V1, so V1 is less than V2, the diode will be in the off mode, it will act as open circuit. So the circuit will be like this. With an open circuit on the V2 side, the current flowing in this circuit is 0. So the voltage of the resistor is I dot R, which is 0. So applying a KVL, we see that V1 equals V2. This means if we want to plot the output value of V2 with respect to time, we see that V1 equals V2. So from here, V1 will equals V2. So V2 will be rising in the same way as V1. So when the voltage of V1 becomes greater than V2 here, from here till here, when the voltage of V1 becomes greater than the voltage of V2, V1 greater than V2, then the diode will conduct. So it will be working in the forward bias region. I will redraw the circuit. It will have a small voltage drop of 0.7. VD 0.7, E 3 volts, V1 R. So if we can see here that V2 equals a constant number, which is 3.7 volts. So in order to draw a constant number for the V2 as output, it's like this. So we will see that when V1 stays bigger than V2, the voltage of the output of V2 will be 3.7 volts. This voltage will stay until V1 drops again below V2. So the V2 value will drop again, reaching 0. So now we finished the analysis of the positive half cycle of the input and the effect of the input to the output. As we can see here, we can see the clipping occurs on the top of the sine wave of the positive half cycle on V2. Okay. To continue the analysis, we will go to the second case. The effect of negative half cycle on V2. Okay. I will redraw the circuit here. The negative half cycle of the input. So the current will flow from the opposite side, from here, but the current will not be able to flow in the circuit because the diode will be acting as an open circuit. Since the cathode voltage is greater than the anode voltage, the diode will be operating in the reverse bias, so it will act as an open circuit. The circuit will turn into two open circuits from V1 and V2, applying a KVL. V1 equals V2. This means that V2 will follow V1 in the rest of the graph. Now we are going to apply this circuit on LT-Spice in order to make sure that we will get the same graph and the same result